Hello one and all, welcome to the Math Magic Show. In this one, we're going to take a look at finding the product of two complex numbers, in other words, deriving the rule that gives the product. So let's go to what I have on the screen here. I have z sub 1 equals r sub 1, multiplying cosine sub 1 plus I times sine of theta sub 1. So that represents our first complex numbers, and I am not going to use e. I am not going to use an exponential. I'm going to do it the hardcore, scary way. Okay. So, next one is z sub 2 equals r sub 2 cosine of theta sub 2 plus I sine of theta sub 2. And our objective is to find a rule for the product of z1 and z2. So what is that going to look like? Let's go through that process. So the first thing will be this. This is our setup. What have I done here? All I'm doing is writing r sub 1 and then the cosine and sine parts of the first complex number, multiplying r sub 2 and the cosine and sine parts of the second number. So that's the setup. Okay, for the next piece, let's take a look here. It's going to look like this. I've moved things a little bit here because at step number 4, the only thing that I've done is I've taken r sub 2 at step 3 and I've moved it and I've placed it next to r sub 1. That's a basic property of multiplication. You can let things float. They can be in the middle, at the end, and front, anywhere you put them, okay? So that looks like that. Now the next stage is you have cosine sub 1, sine theta sub 1, cosine theta sub 2 and sine theta sub 2. Try saying that. We need to FOIL this out because within the yellow there, that's a binomial, and then the other one in the 2 is also a binomial. It's got two terms basically. So when we FOIL that portion out, it's going to look like this. It's going to be that part multiplied by that part. That's going to be pink. Then that same yellow part multiplied by the sine theta 2. That's going to be red. Then it's going to be that I sine theta 1 multiplying the cosine theta sub 2. In yellow, and then blue, I sine theta sub 1 multiplying I sine theta sub 2. Let's actually apply this now. So this is the result down below of doing this multiplication. Let's go through it carefully. So I did cosine theta sub 1 times cosine theta sub 2. That's the pink arrow. That gives me this pink colored term right here. Cosine theta sub 1, cosine theta sub 2. Okay, then I did the reddish arrow. So that's cosine theta sub 1 multiplying I sine theta sub 2. That gives me the term there and the sum in red. Then the yellow part is I sine theta sub 1 multiplying cosine theta sub 2. So it becomes I sine theta sub 1 multiplying cosine theta sub 2. Good. And lastly, the blue arrow will generate the last term. So I sine theta sub 1 multiplying I sine theta sub 2, and that generates the blue term at the end. Just the way you see it right here. So the result right above me, that's the result of doing FOIL on the binomial in step 4 to get step 5. And again, I'm just keeping the r sub 1 and r sub 2 factors just grouped together in the front of everything so they stay out of the bigger calculation. It's cleaner. Okay, so when you look at this, there's a lot of combining of like terms. Let's go through that process. So when I do that, it's going to look like this. And I've removed the color coding here. It's not strictly necessary because we have thetas subscripted anyway, so you can keep track of them that way. So when I do this, it's going to look like this. At the very end, where you have in blue I sine theta sub 1 multiplying I sine theta sub 2 in blue, the i's can be multiplied together to give you I squared in that position, right where I'm pointing with my laser. So that's one fact. There's another fact though, which is that in the red cosine theta sub 1 I sine theta sub 2, and in the yellow you see there's an I in both of the yellow and the red terms. So what I can do with that is place the I outside, and I've done that right here. So the I goes out here as this white I in that position, and the remaining thing I put there within parentheses to indicate that the I has been factored in the middle there at step 6. Okay, I hope you've got that. And the first parts are left, so it's still cosine theta sub 1 multiplying cosine theta sub 2, nothing different. Let's go on. Now after that, it's going to look like the following. The only change I'm making at step 7 is that now in front of the last term, sine theta sub 1, sine theta sub 2, I replace I squared with negative 1. That's the only difference because I squared by definition is negative 1. Now when I look at step 7, again, I want to group like terms. So let's do that next. It's going to look like the following then. It's going to generate step 8. And step 8 is just like step 7, except I've taken negative sine theta 1, sine theta 2, and I put that together with the cosine theta 1, cosine theta 2. So now in front here I have this entire expression, cosine theta 1, cosine theta 2 minus sine theta 1 sine theta 2. Okay, now I also am keeping the cosine theta 1 sine theta 2 sine theta 1 cosine theta 2. I hope to God I'm saying all of that right. I'm keeping that together within parentheses because that's the bit that we generated from factoring I from each of those terms. So when I look at this, what I essentially have within the parentheses, not above my head, those parentheses, but I mean this parentheses by R2 and then the closing parentheses after the I at the end, the giant parentheses. I have basically a complex number. Now, this complex number looks pretty messy, and the question is, can we make it look simpler? So the answer, of course, is yes. And how can you make it look simpler? What we can do is we will be able to take this part, cosine theta 1, cosine theta 2, sine theta 1, sine theta 2, and I'll be able to rewrite that by using a basic rule, for example, for the sine or cosine of a sum of two angles. And then likewise, the same thing will happen over here for the second part for cosine theta 1, sine theta 2, sine theta 1, and cosine theta 2 within the parentheses on the I. So let's do that as the last step, and that will give us really the answer that we need. So when I do that, it looks like this. What I'm doing here is I'm replacing essentially cosine theta 1, cosine theta 2, minus sine theta 1, sine theta 2 with cosine of the first angle plus the second angle. So the cosine of a sum of two angles is what's being used to replace that. And then likewise, for the second bit, cosine theta 1, sine theta 2, sine theta 1, cosine theta 2, that will be replaced with the sine of theta 1 plus theta 2. The other parts, R1 and R2, are kept, and that is the answer. So what is this telling us? It's telling us the following, that when I begin with two complex numbers, given in this form, sines and cosines, like a step 1 and 2, they're next to me, then when I multiply them, in other words, step number 3, the product can be found by doing step number 9. In other words, I can multiply R1 by R2, and I can put cosine of the sum of the angles plus the sine of the sum of the individual angles. That's what it's telling us. Okay, that is it for me. I know this was quite a lot. It's kind of interesting though and a bit challenging. Thank you so much for watching. I hope I've got all the subscripts correct here. Thank you so much for watching. Please leave a like and subscribe, and I will see you in another video.